It's the first part of the afternoon, Sunday 16th, and we are waiting for our participants. TIQIT 25 is about to happen. 40 students from all over Europe attending lectures in quantum physics, knowing the cities of Innsbruck and Trento and having fun. Let's wait for what the project is reserving us.
I liked laser light. I was really fascinated by the properties of laser light. Yeah. And I went to an institute which was quite well known at that time for lasers in Hanover. And they were also doing spectroscopy with lasers. And with the spectroscopy, I got interested in light-matter interactions. Those things developed in step by step. When you see some things, and you see, wow, there's something going on you don't understand in your experiments, what could it be? And you read different things. And in our case, it was the mechanical effects of light. And so I got step by step attracted into the field of laser cooling.
Do you foresee advancements and applications in technology for the future? Does Bose-Einstein condensation contributes itself to some technology that will impact, for example, the life of the society? Do you see hints about that possibility?
Okay, in the future, one trend, of course, is to build more integrated miniaturized systems. Now you can build a small apparatus on BC which you can put in a satellite or something like this. There are first experiments doing interferometry, atom interferometry in space, and these things. And this will give us much more precise knowledge. I think what's also inherent to this kind of basic research is always there are surprises. Something will happen which we cannot really anticipate. Maybe we can find out that having super precise atomic clocks on 10 to the minus 20 level enables some completely new things. But I don't know. It's full of surprises. We're not engineers. As an engineer, you have a certain goal. I do this and that. I want to do it as good as possible. But as a physicist doing basic science, you should have, of course, some interesting directions in mind, but you should be open for these surprises.
Well, that's right. A physicist has the goals of a physicist. But what do you expect from this research in the future years? What would you like it to happen with your team, with the people you are with?
We should be excited by the physics driven by natural curiosity to enter, to do things that no one has done before, with new systems, new materials, and just learn about the properties, characterize it, searching for new effects, and then letting us hope that just randomness and random discoveries will happen, and you find something that is completely new, no one had ever thought about it.
Good afternoon, Professor Ferleiner. It is a pleasure to be here at TIQIT even this year. And I think, and we both agree on that, this has been a history of success. Could you just go on again and go through the history of this wonderful project?
Yeah, last day I was thinking about the first edition of TIQIT and how everything was coming about. And it was really very nice because it was extremely spontaneous. A group of students from Trento had the idea to bring some of the Trento students of physics in Innsbruck to have some talk, visit the lab. And then from this seeding idea it became a little bit bigger with the idea that maybe the student could not only visit our lab, but also the lab in Trento. So we started to cooperate and to have this idea of a quantum tour. And this was back in 2017. And from that moment on, I think TIQIT was growing in one way or the other every year. Of course, we had to stop for pandemics, but beside this, while at the beginning was just for few students from Trento, then in the later edition, we started to add the possibility to every Italian student of master and bachelor in Italy to actually register. And then this was also extremely successful. We had students from South Italy, North Italy, to the east, to the west. So every different region were in a way represented in TIQIT. And then it went European. So at some point, I mean, the Italian Student Association has also, of course, the European counterpart, so the bigger organization. And then I think the organizer opened also the possibility to students from other countries.
What do you think is the advantage of having an opportunity such as TIQIT, and what do you think may be the evolution in the future?
I really could see that TIQIT has a much bigger impact to the life of the student than what I could ever have imagined. So first, because it's probably the first opportunity for young students, so bachelor and master, to see how things are done outside of Italy. Moreover, we are following a path that is not really academic, in the sense it's not only frontal lecture in a lecture class at the university. No, we offer several different aspects of research. So with the lab tour, to get in contact with theory, experiment, to get in contact with a student from Innsbruck, that they can share the knowledge on how it is to work here. So we try to really give a sense of how research is done in general, with the example of how we do here in Innsbruck. And I think that this is really a crash course on research and in investigation. It's probably the first time. So many of the TIQIT students of previous edition then decided to continue with the PhD, for example, to continue research. And I think that this experience was important also to give them an idea of what is actually about to work in a research group, either experimental or in the field.
For me, working in a sort of interdisciplinary way is the most funny way of doing science. Basically, you try to understand many different things, and then the connections come out kind of natural way. I remember when I started my master thesis, it was about photonic crystals, which was the idea of transferring to optical systems the idea of electronic band structure in solids. And this was the first example of interdisciplinary connection that I met in science. And since then, it has always been great to try to connect different fields. Say light and fluids to create the idea of quantum fluid of light. You try to see things not from their face but from their back. And this is the way to discover something unexpected, even in things that you would have considered as completely understood.
Can you just give to our audience a grasp, like a vulgarization grasp of the main idea of your lecture?
See, the main theme of the lecture is interdisciplinarity, is the way how different concepts can be merged to give something new. I started from a quantum fluid of light, where one makes light to behave as a fluid, just by endowing particles, photonic particles with mass and interactions. In this way, one creates a fluid of light. And then, developing on this idea, one can get new states of matter of the photon fluid, strongly correlated states with quantum correlations, or even systems with higher dimensions, synthetic dimensions, topology, which provides new functionality, new effects in optics, which were completely unexpected before that.
it's interesting to look at these undisclosing fields, and this makes me obviously wonder about the future. What do you think your current research may open up to us in the near future?
Say one direction which is, in my opinion, extremely promising is to look at systems in high dimensions. Normally our world is 3D, but the geometry, say, centuries of mathematics has taught us that the ideas of geometry can be extended to higher dimensions. And there one can expect completely new physical behaviors which are not expected at all and which are just there to be discovered. So the idea of synthetic dimensions could be a key for these developments to occur.
I would ask you to just remind the people that are watching our report how good research is done from the roots to the top to the visible, interesting things for the actual society.
So in terms of actually doing this, I think it's important in terms of research. There are many factors, okay, and there isn't one way of doing it. But to think about it in general, it's like how I said that the center is set up. There are the roots in terms of the facilities, okay, so the actual equipment, the techniques we use in the equipment, the way that things are actually done to make things, okay, and of course this includes the capabilities and the creativity of the people. In terms of sort of the branches and the trunk of the activity, this is in terms of the things that you can do with it, okay? So actually technically, for us, we call it technological platforms, but it's the technology that we can actually do with this equipment, with the set of people, with their research capabilities and techniques. And then, of course, that's all very nice and that's very important to the individual person in terms of it, and it's very important to the centre. But what people actually see is how things actually impact on the application. So this is where the impact comes from. So I refer to this as basically the leaves of the tree, and in the case of what we do, it's quite general and broad. So it's a lot of applications, and here, of course, you cannot be skilled in everything, or you cannot be equally skilled in everything. And therefore, this is why I say that for most of the activities, we need to work for application-specific experts, and that they really understand what needs to be done, and they can provide requirements that we can work on to get the best devices for that as a particular application. So I see it as a 3-level process with expertise on each level working together to produce the final result and impact.
Thank you. You mentioned being very strong in a niche as a foundation, but doing lots of other things by collaborating with other people. I would like you to just remind us how important is connecting with other people and collaborating and thinking together.
So I think if you try to do everything, you will fail at everything. Okay, and the analogy of an ecosystem is a good one, because in an ecosystem, if you look at what happens, evolution has essentially evolved living beings to perform very well at the particular environment they're in. But there's an important thing in terms of actually building up the capacity in the region, strengthening the ecosystem, and getting things out. So it's a very important activity from FPK to make sure that these links exist and that TIQIT is supported like this.